Okay, good evening. This is Professor David J. De Los Reyes. Okay, this is my first live video stream after passing the requirements for the YPP. So for tonight, I want to discuss something about my channel. Okay, I am appealing for those viewers who would like to join my channel by just clicking join, and the payment is $2.99. It's up to you if you would like to join or not. But for those who will be joining, rest assured that I will be doing my best to bring out a good video for my channel, much more on the long video format. The long video format is a good one who plans to study a certain subject matter like differential calculus, integral, differential equation, advanced math, college algebra, AC circuits, and AC machines. Because I have uploaded already 7 subjects, a complete syllabus thing for those subject matters. So for those of you who plans to complete a topic on the subject matter, I have got the 7 videos uploaded already. To number the lessons from number 1 till the end. For example, in the integral calculus, I got 100 lessons to complete the syllabus. So you will have all the knowledge to understand integral calculus from the simple integration problems. My technique is I will try to discuss the concept. I would like to express as precise as possible the concept of the subject matter. Then I will try to give example problems. I always write it in the board, then I will just discuss it. Okay, I will discuss till it is finished. I think what you call this efficient and not to pressure those who are not yet expert on the subject matter, because it is written, you will not write it on the board completely. Once you cannot understand the concept, I wrote all my lectures on the board before I will try to lecture the subject matter. For the short videos, and the short videos, uh, I subject matters like algebra, trigo, calculus, integral calculus, not just be accommodated in the 60-second time. So it's just I will write the complete problem on the board, the solution on the board, then I will try to video it. Okay, and I will upload it as a 60-second maximum video. So I don't have to talk, because if I have to talk, okay, that duration 60 seconds. The other subject matters under my short videos are actually like in the troubleshooting of electronics, the things for electronic usage. Gardening side, sometimes I upload some gardening pictures, and on the new kind of food that we are eating at home. Do it, but it is just limited because I just could I will be uploading for the other subject matter. Sometimes we travel outside, like we visit a casino one time, once a month. So actually, I'm also uploading some. I think like for tonight, provide my. I will prepare my lecture, and as soon as I am finished writing on the board, it's a tedious task. It's very tiring, but the writing on the board actually helps viewers because I'm saying is on the board. So actually, it suggests something like this. We are discussing quadratic. So my style is this. If I would like to discuss quadratic equation, meaning the solution, deriving this one, I will bring out the derivation and I will give you the final formula why it came out like that. Okay, so there's no magic in bringing out the final formula. So if anybody is online, you can join me and you can ask questions about my channel. Or anybody is online, please join me. You can ask any questions about the subject matter, differential calculus, integral, differential equation, advanced math, okay, easy circuit, easy machines, or college algebra. I am very more than willing to answer what will be your questions. But for those of you who would like to join my channel, the payment is just only to be a member, $2.99. And the benefits you will be getting is that if I've got a new video which might interest you, you will be the first priority to get notifications to watch my video. But for those who would not like to join my channel, you know, you can still watch my channel. No problem with that one. My channel is just a very simple one. It's a long video format and a short video format. So if you would like to watch my topic on differential calculus, just go to my channel and type in the title differential calculus. So all the lessons from number one till the finish of that differential calculus will all be there. It is in sequence. The integral, it's also like that. Differential equation, it's also like that. If you would like to watch my long video format on advanced math, just go to my channel, type advanced mathematics, and the subject matters under advanced math is were numbered from number one till finish. It's a complete thing. I'm not telling it's complete, but more or less it's 80% to 90%. If I have forgot some other topics under the subject matter, you could just give your comment and I will add up something on it. Like in the college algebra, we started with the fundamental operations. Okay, the fundamental operations is actually the basic of algebra. Because in the simplification process of solving an equation, it's all algebra. It is all your knowledge on the so-called fundamental operations. For the sequence of operations, oh, that is very important because if you try to simplify a certain equation and if the sequence is not correct, your answer will be wrong. The other subjects I am uploading on what they call this short videos are actually troubleshooting techniques. I am a troubleshooter. I have finished troubleshooting here in the USA, and I've been troubleshooting electronic equipment and gadget for so many years. So I'm familiar with the multimeters or the other parts being used, and I've got all my equipment over here. The parts I've here, like I will try to bring out the schematic that I've been using before. The schematic are actually the brain work on how to troubleshoot, because to trace the circuit where the circuit was cut off, okay, because the equipment was inoperative. Okay, you will analyze it through a so-called schematic. Okay, this is a schematic diagram. So whenever you troubleshoot a complicated circuit, we are using this one. But if you've been troubleshooting for a long time, actually, like in the power supply thing, actually you memorize already the what you call this variations on how the circuit is actually designed. For multimeters, I got more than 5 multimeters. These are my multimeters. So one multimeter could what do you call this check so many components like in the so-called continuity test, the measurement of a DC voltage, the measurement of an AC voltage, the measurement of the frequency, how to check a diode if it is good or not, how to check a resistor if it is open or still intact for a diode, whether it is short circuited already or open circuited. So these are the multimeters I'm using. There are lots. Oh, these are digitals. I've got still the old style, the analog thing, but this is a thing of the past. Okay, this is analog. This actually operates by a pointer that is moving like that. For the digital, you just read the number here. It is just like a calculator. No more adjustment, much more on this. This is more of a thinking tester than the digital, because this one you must have to adjust it to the correct setting for you to get the correct uh, parameter for this. But for the digital, if you are measuring capacitor, you just set it on the capacitor thing. If you want to measure current, you just put it on the current, and that's it. The reading will just be automatic, a number will just come out. These are my electronic parts. Okay. It's a complete thing. It's from 1 ohm to 3 million ohms. So just in case you're troubleshooting, okay, you need 100K, you go to the 100K, and that's it. You could check the value of the resistor, you got your tester. If it says 100K and you measured 99.5K, that's more than good enough. Because resistors got the so-called tolerance. It's either plus or minus 5, plus or minus 10%. And these are all electrolytic capacitors. These are the capacitors. Electrolytic capacitor. These are used as a support component in the design of what you call the circuits. The usage of this is actually sometimes it could be like a filter, something like that. The one they are using to eliminate the humming sound for the speakers are actually this one. Before the speaker, you connect a capacitor like this. So when the sound passes through this, okay, the humming sound cannot pass, or a DC voltage cannot pass by this, but the sound can pass by this. So without this, sometimes if the design of the receiver is no good, the sound is actually dirty, and to eliminate that humming sound, we use this one. These are capacitors. With whatever value you will use, like this one, this could be the capacitor maybe for a rectifier to filter out the pulsations of the alternating current after it was rectified by the diode. Okay? So in the troubleshooting, you should know if the capacitor is still good or not. Like the resistor, the troubleshooting of the resistor is straightforward because a resistor is just like if it is burned, it's open already, no good. Okay, so if you try to use the tester, if it doesn't sound, it's open. You just throw it. That's the troubleshooting of a resistor. How about for a capacitor? Capacitor is different. This one, if this is a big capacitor, it got a residual voltage, like the capacitor for air conditioner, maybe as big as this one. So when you are troubleshooting the air conditioner, don't ever try touching the two terminals. Before you touch it, okay, you try to short the two terminals with a screwdriver to remove the residual voltage there, because there will still be a residual voltage which might kill you. Okay, that is for big capacitors, not for small capacitors, like the high voltage ones. I will show you a big capacitor which are used in the power supply of amplifiers. These are actually the filter capacitors for amplifiers. This one is high voltage. It's a 200 volt, 1000 microfarad. So meaning to say, if the rating is 200 volts, it's still possible that there is 200 volts inside. So before trying to touch the two terminals, try to short it out. Okay. Okay. Filter capacitors for power supplies. Oh, that's how I work. What I am teaching you, I have done it already in actual. So it is not just a hearsay. It's an actual thing. Even in the so-called what do you call this soldering, if you are no good in soldering, okay, soldering it's just like you are a surgeon. Your hand should not be doing like that. Your hand should be steady, poking into the solder to be removed. I got 5 soldering guns over here. It is from the big gun to this is a soldering gun. This soldering gun is for the tip is very thin, so we could use it to desolder maybe a 24-pin integrated circuit. When my eyes were still intact, I could unsolder that one very fast. This portion is actually the variable current supply. If you want to call off the what you call this the tip, if you are not using it, put it in the low side. If you are using it and you want maximum heat, put it in the maximum. Okay. So the tip of the soldering gun will not what we call this destroyed. Because if it's too hot and you are not using it, okay, this will be melted. It will not last long. So if you are not using it, try to put the setting of the soldering gun to the minimum. Okay, so to avoid preheating when you will use it, at least it is heated. So when you need the maximum heat, you just put it in maximum. Okay, and you could do the work immediately. I got my oscilloscope over here. There are lots. I've been troubleshooting for a long time, so what I'm saying is the real thing. Okay, these are my testers for checking high capacity transistors, the TO3, the one being used for big amplifiers, TO3. You just connect the 3 terminals to the collector, base, and emitter. Okay, then just rotate this one. If there is no sound, okay, that transistor is actually no good already. So there will no be guessing if that transistor is actually defective or not by using this one. This is for heavy duty transistors, TO3. TO3. The one like a, what you call this? It's a big one. You try to remember this one? This is actually the gadget to remove the smudge of the coloring on the old TVs before. Okay? You remember that the TVs before, the old analog one, where the color was a little bit, it's not concentrated already because it was magnetized. To bring back the original color of that one, we use this one. We plug this one on the, what do you call this, outlet. Then we try to move this one, we move from the screen going down like that. Then we go down, go out. Okay. When we are far away, we shut off this one and the color of that old analog TV is, return to the normal thing. This is the one we are being used. I think for the new TVs, this will not work because for the new televisions now, they are LCDs and LEDs, right? Unlike before, it was a picture tube. So that picture tube in front is actually could be damaged by what sometimes if you are vacuuming, Okay, the color of that will, it will be contaminated. It's not a perfect color already. You will see like it's a faded color. This is the one we are using for the analog TVs before. This will not work for the new TVs because the new televisions now, the big screens, are LEDs and plasma, something like that. So regarding experience on the electronics, if I talk electronics, it's not hearsay. So I am feeling for those who would like to join my channel, please join my channel. If you would like to ask anything about troubleshooting and electronics, you could ask me. If you would like to ask something about the subject matters, differential, integral, differential equation, advanced math, and other subject matters on my channel, I am more than willing to, tutor you. Okay, somebody's there. Nobody's joining me. Okay, this is for now. So I will repeat it before I will go. I will end this live stream for tonight. The contents of my channel is long video formats on the subject matter differential calculus. It's a complete syllabus. So if you would like to learn the subject matter from end to finish, it's all there. Differential calculus, integral calculus, differential equation, advanced math, college algebra, okay, AC circuit, AC machines. Maybe my next topics may be higher subjects on the electrical engineering side, maybe a power transmission subject matter. It's a sub calculation of transmission cables. Okay. One example of a sub calculation is the San Francisco Bridge. I think the San Francisco Bridge, it's not a parabolic curve. It should be a hyperbolic curve. You know why that cable is something like that? And every vertical connection is actually got a tension force on that one. We could solve those ones mathematically, and those are subject matters under electrical engineering. Much more on the power transmission. Power transmission meaning if a power plant will generate voltage, the one we are using, it could either be a nuclear, hydro, or it could be um, what do you call this, solar. Like in the Philippines, we got the geothermal thing. Geothermal is actually uh, a hot fluid coming from inside the earth, and we try to tap on this one. So instead of burning oil to heat up the water to make a steam and we'll move that steam engine, we drill something like inside the earth. So it will pop out as a heated water, and that's the one they're using to run a steam engine. So no more cooking of water to run the steam engine in the Philippines. We got those ones. But in here in the USA, you got the nuclear, you got the hydro, you got so many things over here. They try to implement this so-called solar thing, but solar thing is limited only for during the daytime. Okay, at least if you are using solar, you could use it during the daytime. But if you try to save energy and use it during the nighttime, it's very expensive because if you try to buy a solar battery, it's very expensive. For me, I got my solar thing down. My inverter is rated 2.5K and 4K. And my inverter, actually, I'm using it for my washing machine and dryer over here. I did it myself. I got my solar panels at the backyard. So during brownout or blackout, we got still electricity here. I got so many solar batteries here. So just in case there is brownout, I could still run my computers or, Okay, that's it, guys. This is Professor David J. De Los Reyes. The next time around, uh, just give me a comment on this live stream and just tell me what topic you would like that I will discuss it live. I've been more than willing enough to discuss it live. Okay, this is Professor David J. De Los Reyes from Los Angeles, California. The time is 12:02 EM. It's now October 3. Good evening.